Hi, welcome to this video on my fischertechnik robo interface with connection wireless to the data link and through USB via USB hub to the BeagleBoard Classic, and the combination currently drives a motor mounted on the wheelbase, this wheelbase, with a propeller, and that goes as long as the program runs forward and backwards depending on this sonar. Last time I ended by adding a switch, this switch, which upon touching should engage this light, but that light didn't go as I intended. Also the question is there a delay because of the data link? So the first thing I want to test is the delay, and I will do that by first running it through the data link and then taking away the data link and putting the USB straight into the controller. So let's first see how everything works in the current situation. On the laptop I start the program, and it says there is no interface, which is correct, because I have to put on the power and now you can see the interface starting. So I'm doing it once again, and this time it works. That ends. Oops. And you see the drag is remarkable, but intention of this test was to see about the delay. And so the next test is putting the USB into the controller. So now it is directly connected. And this, well, is an empty box right now. Well, not empty of course, but disconnected. So let's try again. Where does it work faster? And that answer is yes, it does. So let me end it for now and start again. So yes, the data link is delaying the whole thing. So for the future experiments I will leave the data link out unless I intend to do some different things. Data link is nice, but I think unnecessary for this set of experiments for now. The next thing I want to try is to get the light right, and for that I will first go to screencast. When looking at the program, it is clear that this can stay the same, because this is the serial number of the interface and not from the data link. Enable distance is from the sonar. Number of devices will put 1, as you can see here already. Distance will be measured, and as far as the light of the lamp goes, this is the part to check. So if the input goes 1, as shown here, digital will be printed. Again, this is the line to look at. It will be set on half the brightness, sleep for 1 second, so it goes on for 1 second, and then I should add another sleep here, because if I don't do that, and that is probably the culprit right now, it will just be on longer than it will be off, and until it goes into this loop, the lamp will be off, and then it will stay on, and that I think is the culprit, apart from the fact that I'm curious if it actually touches the that is, if the carriage for the motor actually touches the sensor, because last time, after some careful looking, it didn't, and that is something I really want to do. This can stay the same for now. So with this slight change, addition of a sleep, it's time to try once again. Is this alright? Yes, I think it's alright. Save and go again. So with the sleep of 1 second added to the lamp, let's see what happens. Well, that's an improvement. However, that is definitely not supposed to happen, because the lamp should go on upon touching the light, the sensor, not when it's back with the sonar. So this is exactly the other way around. And another thing is that although it touches the sensor, it doesn't press it. So I will put at least one of these in here, between this and this part, so that it comes closer to the carriage. But also I have to look into the code to find out why the lamp burns on this side instead of on this side. And more logically reasoning, it shouldn't actually be burning at all, since this sensor is not pressed like this. This should be happening first before the lamp burns. So that doesn't make sense at all right now. First let's add one of two of these right here. Okay, there's one added, and let's run it again, see if it is actually pressed. And the question is, no, it is not. So let me add another one. So this one goes here. And see if it is pressed now. This is curious because although it certainly reaches it, it's not pressed. Another thing I notice is maybe that this is too flexible. The first thing to check is the code to see why the lamp is turning on in exactly the wrong place, here instead of here, because right now, since the sensor isn't even pressed in, the lamp shouldn't even burn. So that's a bit odd. So time to check with the code again. When looking at the code, there are some things that I set up during the initial idea. However, after adding things, it doesn't really match anymore. For instance, this is a nice idea, but it has, as it shows, a limit of 5 centimeters. That limit is set by me. Now when I look at the carriage in its furthest location away from the sonar, it is 7 centimeters, and that is measured until the vertical stand of the motor, not the carriage and not the motor itself. So when I say 5 centimeters and then it goes, then the power is already cut, and not the power is cut, but the direction is reversed. So with direction reversed, the power to go on is of course completely gone. So I actually should put this to, for instance, 8. See if that helps in touching the sensor. Then would it help to keep the motor running for 4 seconds in the reverse direction? I think so, because as we have seen, the power is large enough that the fan keeps running while it is already near the sonar, so that should not be a problem. Another issue still remains is the digital 8. It is an input, and no matter how you look at it, it is strange that it goes on when it is in the other way. So is this a delay? Could be, but what I will do is to make sure that there's nothing else going on. Say 7, and this is 7. It should say 0 at any time, because there's no connection to it. And let me put 6 as well. With this, I'm sure that the values are the way they really are, and only 8 can change, or should change. With that thinking, there's another thing. This should sleep for 4, and right now I'm not quite sure that is going to work, but let's see. So save and run again, first to see if there's no problem. There we go. And the light is flashing, but the motor doesn't stop running. So that is something that is not quite alright. If I turn it to for instance 6, let's see what runs then. Nothing either, although these values are seemingly correct, because now the motor is not coming back, and that should be the case. Okay. And let me show you what happens on camera, because this is a little bit weird. Let me put it to 5 for now. And I've put it to 5, and now it runs back and forth again. So apparently the 5 is okay. But on the other hand, there is another issue, and I should really go to camera for that to show. So right now with the distance back to 5 centimeters, when I put the track back to its original position, it doesn't really press or make contact to the sensor, but the sensor responses, so that is still odd. And let me show what happens when I put the distance back to, say, 8. Then this is what happens. That is not what I want. What I clearly want. And this is with the distance set to 6. And back to 5. And another thought that I have, and that may be due to the track itself, let me leave this off, it's quite bent. And here it's not connected either, so I may have to change the track so it is really horizontal and that it is connected here as well. That said, oops. Take out the wiring. All the wiring. Let me run it again, see what happens. It's not as stable as possible because the motor is of course located on the left side and not in the middle, but apart from that I don't see why it shouldn't work, apart from wires not staying where they should be. Anyway, this shows that it is also time to reroute some wires and see where that leads. I did two things on the hardware level. I put, or tried to put, the motor more to the middle of the carriage, and I reconstructed the railway. Now the tracks are connected on both ends, and in order to prevent the wire to disturb the distance measurement, I put a cable guide on top. And I found that I had made a slight mistake, so I had to use other parts here, so now it is not 3 level high but 2 level high. And I do hope that this makes sure that it works. So let's try again. starting the current program. And I think I better should hold the tracks, and well, once again it's not going as intended, not at all even. Still the light burns when it's here instead of there. So what happens when I put everything up? No, I better not. So I think it's better if I reconstruct the carriage, because obviously the wheels are not entirely equipped for running the rails. On one hand they are, well, it's not going as I hoped it would go. So what else can I do? Obviously it is being held here, but I have to find out why it is not pushing in. Maybe the blade in here is just as strong as this, as the power by the fan, and then it won't make contact. Another thing I can do, I didn't think of that, is to try with the diagnostics interface to see if this indeed makes the right contact. And for that I think I'd better do that. So let's try the FT Diagnostics. That is, if I can get it to work. It should be in here, and then that's another point. And then ft diagnose.py. There we are. I have to open the interface first. Yes. And then see, and that's the point. And now when I press it, I have wired it the wrong way. Now it's out. Now I press it and it stays out. Another rewiring, and this is the way it works. So this is for one thing. And now it's not necessary to check the sonar, because that obviously works, although I can do it, but I have to reopen it and select distance mode. And let me check if that works. It works kind of. If you look here, it is 6. But it is not really nicely working. This is 6. So this brings up the question, does the sonar indeed give a constant reliable value? At this moment, when I look at these results of D2, I am inclined to give the negative result. How can I change this? By putting the wire somewhere that the sonar doesn't detect it. So anyway, the diagnosis showed that the input was wired wrong. So with this result, let's see how this works. If it works, I'm very curious now. And yes, this is not because of distance obviously, but because of the sleeping, because the distance gives totally wrong values. Always over 5, never under 5. And what I can do about that, is oops, this must be 2 obviously. And of course I can do this for larger than no, that's because I'm doing this here as well. So let me just copy this. Okay, this is annoying. Let's just see if this works out. So apparently it does work with a very small margin of 6 to 4, 6 to 4. And now, because of the rewiring of the touch sensor, nothing is printed. So it obviously does not print. It does not work with touching. So what shall I do that this does work? And someone told me the fan could be heard through the microphone. It is indeed making quite a loud noise. A point is, by the way, although I intend to keep to get the sleep out of here, I don't think that would be wise, but because I have to keep the action going. But let me try to do that. What happens if I do it this way? Yeah, no good. No good at all, because it then from 1 second to another it switches between clockwise and counterclockwise. That's not the intention at all. Anyway, some errors taken away. The little bit of reconstruction, but the sensor remains a point of worry, so that is up next for another time. But let me go back to the camera and show the current functioning of the installation. So, as a conclusion of this episode, let's go through the wiring. This wiring is fine for now. This wiring is, I think, outside the three-dimensional cone that senses the carriage. The track is bound, but although it bounces really against the sensor, the sensor isn't being touched. The drag is quite high, but as said, this combination should be looked after, with the light and the sensor, and maybe the track as well. Yeah, there remains a lot to be improved, but so far it is nice experiments ongoing. So for now, thank you for watching, and certainly to be continued.